Okay, so again, as you guys know, I am away today, and you guys know the drill by now. We're going to do a video lesson. So this is the last lesson of the entire unit, and then tomorrow you'll have a review day. I'll be back in tomorrow, and then on Friday you have your Unit 3 test. Okay? So we're going to go over applications of linear relations. We're going to talk about different types. Application just means word problems, essentially. So we're going to look through different word problems. We're going to look at how to analyze a table of values, so something like this, and answer a bunch of questions. It's kind of short. It's just one page back and front, and then the rest is the practice, and you guys know practice means homework. Okay, so I am checking tomorrow that the practice from yesterday is done, and the practice from today is completely done. Okay, so I'll be checking that tomorrow. All right, so let's get started. So we have applications of linear relations. So it says the following table shows how much 4 different households in Halton spend on water each month. Okay, so we have our X and we have our Y. This here, this customer ID, don't let it intimidate you. Let me shift that a little bit. This here, customer ID, don't let it intimidate you. This is actually unnecessary information. Okay, you have your X and you have your Y like normal. So A right away says calculate the rate of change. And we know rate of change means we need to find the change in Y and the change in X. So we have here, we know rate of change equals change in Y over change in X. But in order to figure out what our change in Y is and what our change in X is, we need to calculate first differences. So let's do that. So from 27.15 to 28.43, we have actually added 1.28. From 28.43 to 30.99, we've added 2.56. From 30.99 to 34.83, we've added 3.84. Okay, now we'll look here. So obviously those aren't the same. So if all my changes in X are the same, but my Y's are different, then this is obviously not linear. However, if I look here, here I added 1, here I added 2, and here I added 3. 2.56 is double this anyways, and I went up by 2. 3.84, is triple that amount anyways, and I went up by 3. So we're okay. So my change in Y is actually, we'll use the middle one where we go up by 2. Okay, so we'll do 2.56 over 2. So when I went up by 2.56, I went up by 2 for X. Or you could have done 1.28 and 1. Okay, and then we find that our rate of change is $1.28 per meter cubed. We have to use our units. So dollars is Y, so dollars per meter cubed. Okay. What does the rate of change represent? That's question B. Well, the rate of change, if we're talking about water usage and the cost, we want to see, okay, how much money do we spend on water depending on how much we use? So it represents the cost of water per meter cubed that's used. The rate of change represents the cost of water per meter cubed that is used. Okay, this is also called the consumption charge. So how much the consumer is using. We are the consumer, the user of water. Okay, then it says to calculate the initial value. So here I can see, okay, my x starts at 9. I want to know when x is 0. What do I do? So if my rate of change is 1.28 for every individual increase in x, then I need to go back 1.28 9 times. So I'm going to, okay, my initial value equals my last y value, so 27.15, and I need to take away my rate of change, 1.28. I need to take that away 9 times because the last value I have here is 9. I need to get to 0. Okay, so when I do that, I'm going to get 27.15 minus 1.28 times 9 is 11.52. And that is going to equal, initial value equals $15.63. Okay? Now, what does the initial value represent? Well, the initial value represents the monthly charge to have a water service. So I haven't actually used any water yet because it says water usage. So if my water usage is 0, because I looked for term 0, that's my initial value, haven't actually used any water, but I still have to pay $15.63 just to say I would like to have water in my household. Okay? So it is the monthly charge to have a water service. Kind of like a starting fee. Okay? In this case, we can call it a service charge. This is how, like for the truck example yesterday, we had a truck, I think the starting rate was just $100 you had to pay even to just rent the truck, and then it was $75 per hour after that. Okay, now we have write an equation for the cost of water, which is going to be represented by C, for n cubic meters of water used. Cubic meters, this is meter cubed. Okay, so here we write the equation. We know the cost will equal our initial value, $15.63, plus my rate of change times the number of cubic meters of water I've used, which they want me to represent with N. Okay? Now, using this equation, it wants me to calculate the cost if I use 11.5 meter cubes of water. So I'm looking for C. I want to find the cost. So this is my equation. Okay, I want to find the cost if N, the number of cubic meters of water that I used, is 11.5. So here I'm going to write, okay, 15.63 plus 1.28. But instead of N, I'm going to say, okay, the number of water that I've used in cubic meters is 11.5. So then I have, okay, 15.63 plus, this is 1.28 times 11.5, which is 14.72. You add those together for a total of 30.35. And then you can say, therefore, it would cost $30.35. Okay? Now, G says, state one thing that you could do to reduce your water usage. So this is just like a personal reflection. You can write anything here. You could write, turn off the water when you're brushing your teeth. You can write, take shorter showers. You can say, well, when I'm putting soap on the dishes, don't have the water running. Okay? So things like that is what you would write here. Just one thing. Okay. Now on the back side, we have the cost of a vacation, flight and hotel stay, so everything included, is shown by the equation C equals 900 plus 150N, where N is the number of nights. Okay, so complete the following table below. So they've told us that this is the equation for the number of nights. The cost is C, the number of nights we stay is N. So if I'm staying for 4 nights, I need to now figure out, okay, if I stay 4 nights, how much am I paying? Well, C equals 900 plus 150, and I'm staying for 4 nights, okay? So if you do that, you can do the math, and you are going to get 900 plus 600 equals 1,500, okay? So you are going to get 1,500. Now I want you to do that math for each of these. You're going to plug in for 6 nights instead of 4. You're going to put 6. You're going to get 1,800, 2,100, and 2,400. Okay? So then, that's all we had to do. It says complete the table of values. Now B says determine whether each of the following statements is true. It costs $150 each night to stay at the hotel. Well, I know in my equation is the cost equals my initial value plus my rate of change times n. If my rate of change is 150, that means each night it's 150. Okay, so this is true. Then it says the cost of the flight was 150. That is false, because if I haven't stayed at all at the hotel yet, the only cost I've spent is my flight, which is $900. So false. The flight was $900. And then it says the cost of the first night is $900. Well, that would mean for just one night, let's see, C equals 900 plus 150 times 1. That would mean for one night, I'd get 900 plus 150, and I would get 1,050. So that is false. Okay? The cost would be $1,050. Okay? Now C says upgrading to a better room would cost $75 more each night. Write a new equation for the cost of the vacation. So upgrading to a better room would be $75 more per night. Right now, it's $150 per night. 75 more than 150 is 225. So I'm going to go, okay, well, first of all, I was spending 150 per night. If I add 75 to that, I'm at 225 per night, which means my new equation is going to be my cost equals the cost of my flight, which is $900, plus my new rate of change times the number of nights that I stay. Okay? And then lastly, we have another company offers a similar vacation. The cost shown on the graph. The cost is shown on the graph. How does the cost of the vacation compare to the first one? So let's see. We look here, and right away on our graph, I can say, okay, right here, that is my initial value. I have an initial value of $800, which is already different than my original equation. My original equation, my initial value is 900. Now let's see my rate of change. My rate of change is my change in y over my change in x. Well, what is my change in y? Let's go from this point to this point. So I have to go up. How much? I went up 200, and I went across 1. So my rate of change would be change in y, which is 200, over change in x, which is 1. Whoops. There we go. Which means $200 per night. That means my equation would be C equals 800 plus 200n, because my initial value plus my rate of change times n. And I can conclude by saying, therefore, the flight is $100 cheaper, but the hotel costs $50 more per night. Okay, so that's it for this lesson. Make sure you do the practice questions as homework, and I will see you all tomorrow.